Hello, in today's session we are going to talk about the color difference signal and unsuitability of G minus Y for the transmission. So to understand how we are transmitting the color difference signals and what color difference we are transmitting along with luminance signal, we must understand first our color television camera. So if you see your color television camera, here you will find there will be the light from the scene which falls on the zoom lens package, and then you are having a special type of mirrors which are called as the dichroic mirrors, and they allow only one wavelength to reflect or to one wavelength to pass through it. So I have a three dichroic mirrors for red, green and a blue. Then when it red generates, it is passes through the red color filter and given to the red camera. Now, as we know that luminance signal is nothing but the 0.3R, 0.59G plus 0.11B. They are scaled appropriately with the resistor. So you can see here resistor 1, resistor 2, resistor 3 and resistor C, which will generate a final Y luminance signal, which is nothing but the 0.3 VR plus 0.59 VG plus 0.11 VB, whereas VR, VG and VB, these are nothing but the voltages, respective voltages of red camera, green camera and the blue camera. Now let us see what kind of output these cameras will give you. So if you see here, if this is one horizontal line, and in this one horizontal line your screen is having red, green and blue color. So for red color, my red color camera output will be 1, or you can say the maximum. Say we are generally assuming that the highest output here is 1, because the luminosity associated with black is 0 and white is 1. So you can say the luminosity or the red camera, if it is 1 or purely saturated color, then you can say it's a 1. So green, for green camera output will be 1 and other will be 0. Blue camera output will be high and others will be 0. Similarly, if you are having a red, and these are nothing but the shades of red, so red, for red camera output will be high because this is a saturated red. What about pink contains, say, a bit higher amount of red and lower amounts of other colors. That's why the respective output will be given on the respective cameras. Pale pink, again the red contents will be less and other contents will be more. So you see here the decreasing amplitude of the red camera output indicates the effect of the color desaturation. Now let us talk about the luminosity associated with respective color. So luminosity is nothing but it's the intensity of light regardless of the color. So here if you see the same kind of things, you will find red VR output will be 1, green VG output will be 1, blue VB output will be 1. Yellow is the combination of red plus green, and that's why both camera outputs will be high and blue camera output will be low. White, all three colors present, and that's why all three camera outputs will be high. Now we were talking about the luminosity associated. Now white is nothing but the combination of all three colors, okay? And we know that when lumen or luminosity will be indicated by 0.3R plus 0.59G plus 0.11B. So if we are talking about the luminosity, or if you are talking about the luminosity of the white color, so white color luminosity will be 0.3, R saturated, you can say G saturated, B saturated, so 0.3, 0.59 and 0.11. Combinedly it will be 1. Yellow is the combination of red and a green, so 0.3 and 0.59 gives you 0.89. So if you see the calculations here, for right R plus G plus B, R put 1, G1 or B1 अगर आपने यहाँ पे डाल दिया तो you'll get a Y is equal to 1. When you talk about the yellow color, you put R is equal to 1, G is equal to 1 and B is equal to 0. So it comes 0.89. C and G plus B, 0.59 plus 0.11, only G component and only B component, so 0.7. Green, Y is equal to only the basic color, that is 0.59. So you can, or primary color 0.59. Magenta, R plus B, and that's why it will be 0.3 plus 0.11 becomes 0.41. Red, again the primary color 0.3, blue again the primary color, it will be 0.11. So these are nothing but the luminosity associated with each and every color, and these colors are arranged according to the decreasing luminosity. Okay, so these are the intensity levels associated with each and every color. So you will see white is having the maximum intensity, maximum luminance, and your black is having the, so blue के बाद अगर आप black place करते हो तो it will have a 0. ठीक है? So this is all about the color bar pattern. These are the calculations. Now how we are going to generate the color difference signals? As we have already talked about the color camera, your color camera is having a red camera, green camera and the blue camera. You are getting Y here. Okay, how you are going to get a Y here? 0.3R, 0.59G and 0.11B. Then it is given to the Y amplifier. This luminance signal will be amplified and given to the Y inverter. Now this inverted signal will be given to the red camera output and the blue camera output. So you can see here your R minus Y and B minus Y components get generated here. So you will get here R minus Y and here B minus Y. So this is nothing but how you are generating color difference signals. So we have seen the production of luminance and then we have seen the color difference signals. So if Y is equal to 0.3R, 0.59G, 0.11B, then R minus Y will become 0.7R minus 0.59G minus 0.11B, and B minus Y is nothing but the 0.89B minus 0.59G minus 0.3R. So this is the generation. Now compatibility consideration. So compatibility consideration tells you अगर आपके peak whites है और अगर आप उसको कलर टेलीविजन पे देखना चाहते हो तो वाइट वाइट ही दिखना चाहिए, ठीक है. इट शुड नॉट रैंडमली गिव यू एनी कलर. So you can see the color difference signal equals 0 when white or gray shades are being transmitted. So if white colors are transmitting, your R is equal to G is equal to B is equal to 1 volt. Now then what will be the color difference signals in this case? Then Y is equal to 0.59 G, 0.3 R, 0.11 B, ठीक है, is equal to 0.59, 0.3, 0.11 का addition, which is nothing but the 1 volt. R minus Y, R is 1, Y is 1, so 0. B minus Y, 1 minus 1 is 0 because my RGB are 1 volt. So when you are transmitting white and you are trying to reproduce it on a color television, your color difference signals will be 0 in that case, and only luminance signal will be shown, which is nothing but the white. Now what will happen on the gray shades? R is equal to G is equal to B. Suppose any voltage in between 0 to 1, because we are scaling our luminance signal in the scale of 0 to 1. For 0 you say it's black color and 1 is nothing but the white color. So somewhere here you are having your gray shade, and let us say it is V volts. So, and as this is the gray shade, does not contain any color, R is equal to G is equal to B, V volts. So Y is equal to 0.59V, 0.3V plus 0.11V, उसका addition is V because इनका 1 होगा voltage. R minus Y component, V minus Y, V will be 0 and B minus Y will be 0 volt. So luminosity associated with that color will be only V volts. ठीक है, so this is nothing but the how you are generating monochrome signals on a color television, because there the color difference signals will be 0 because my signal is monochrome. Now next one is nothing but the unsuitability of G minus Y signal. So before starting with the unsuitability, we'll talk about the polarity of color difference signals. So we will see you are having this kind of color circle. So on this axis you are having a B minus Y. How we are transmitting signal? We are transmitting two signals. One is B minus Y and R minus Y. ठीक है, so आपका B minus Y x axis पे है, R minus Y y axis पे, negative x axis minus B minus Y and यहाँ पे minus R minus Y. ठीक है, so here you are having the magenta color, red color, orange color, and then somewhere here green color and a light blue color. ठीक है, so these shades appears. The modulation technique which we are using for color is the quadrature amplitude modulation, and we are going to cover this in the next sessions in very detail. Right now we understand we are putting our color difference signals on x and y axis, like x पे आपका b minus y है और y पे आपका r minus y है. Next one is nothing but the unsuitability of G minus y transmission. So we know that y is equal to 0.3r plus 0.59g plus 0.11b. So I'm going to split this equation 0.3, 0.59, 0.11 into y, which is nothing but the 1y. So this is 0.3r plus 0.59g plus 0.11b. ठीक है, so अगर मैं हर सारे टर्म्स एक जगह पे ले लेती हूँ तो इट बिकम्स 0. I'll say 0.3y, ठीक है, या फिर r minus 0.3y plus 0.59g minus 0.11 59y plus 0.11b minus 0.11y. ठीक है, so this becomes 0. I'll just separate out common terms, that is 0.3 r minus y plus 0.59 g minus y 0.11 b minus y. So if I want to extract, or if I want a G minus Y signal at the receiver side, what I need to do, I need to say 11 B minus Y, ठीक है. So G minus Y signal, दिस इज माइनस, ठीक है. आपको क्या करना पड़ेगा, 0.3 डिवाइडेड बाई 0.59 आर माइनस वाई plus 0.11 by 0.59 b minus y. And if you see these factors are nothing but I'll see 0.508 r minus y plus this is 0.186 b minus y. So these are nothing but that's if I'm saying 0.5 means half of the r minus y. So you need to use a attenuator, or simple resistor can be used as attenuator. So G minus Y signal can be derived from other signals by using a simple attenuator, simple resistor with the both signals, or with both the color different signals, that is R minus Y and a B minus Y. Now let us take the example, or let us take the condition where you are not transmitting B minus Y, ठीक है. I'm taking the condition जहाँ पे मैं B minus Y not chosen for the transmission. So how you're going to derive that B minus Y? 0.11 B minus Y is equal to 0.59 G minus Y plus 0.3 R minus Y. So आपका B minus Y signal अगर आपको चाहिए इनसे, तो you will just 0.59 0.11 G minus Y plus 0.3 by 0.11 R minus Y, and which comes 5.36 G minus Y plus 2.72 R minus Y. So you can imagine how much scaling factor you need to derive or to get a B minus Y out of G minus Y. So 5 times larger, whereas you need to use the amplifiers, not only single amplifier but 2 to 3 amplifiers in that circuit. Here also you need a 1 or 2 amplifier in the circuits to get that signal. So it's always difficult to design amplifier, ठीक है, and that's why we are not choosing B minus Y. R minus Y is chosen, not chosen, and you are going to derive it from other colors, then it will become 0.3 R minus Y, 0.59 G minus Y, 0.11 B minus Y. So you can extract your R minus Y from other two colors by, say, I'll just put here 0.3 G minus Y plus 0.11 by 0.3 B minus Y. So here if you'll see the scaling factor here will be 1.96 G minus Y plus 0.366 G minus Y. So sorry, B minus Y. So if you see here आपका G minus Y का जो scaling factor है वो दोनों भी condition में बड़ा है, it's close to 2 and it's close to 5. That's why if you are choosing G minus Y for transmission to extract other colors, you need amplifiers in the circuitry, which is very difficult to design, and that's why we are transmitting B minus Y and R minus Y along with the Y signal. So you can see here, if R minus Y is missing signal, its matrix would have been like on the expression 0.59 0.3 G minus Y 0.11 0.3 B minus Y, ठीक है. So you can say here हम लोगों ने R minus Y को extract करने के लिए we have already seen which needs 1.97. It implies the gain in the matrix and thus would need a एक्स्ट्रा एम्पलीफायर. सिमिलरली अगर आप B माइनस वाई नहीं भेज रहे हो तो आपको यू कैन सी दिस फैक्टर वी हैव कैलकुलेटेड 5.36, वो आप यहाँ पे 5.4 है और ये 2.7 है, बोथ इम्प्लाइज गेन एंड यू नीड टू एक्स्ट्रा एम्पलीफायर्स, ठीक है, एंड इट विल बी required to get that much of a gain, ठीक है. So why in addition since the proportion of G minus Y, if you see the proportion of G minus Y, अगर आप यहाँ पे Y में देखेंगे आपका proportion क्या है, यहाँ पे 0.3 R 0.59 G plus 0.11 B. So आपका proportion of green is greater or the relatively large in most the cases. So the amplitude of G minus Y is small. अगर इसका proportion ज़्यादा है तो उसका जो भी amplitude होगा G minus Y का वो small होगा. So it is either the smallest of 3 color different signals or is utmost equals to the smaller of the other two. That's why your signal to noise ratio will be lesser. So you can say the smaller amplitude together with the need of gain in the matrix would make signal to noise ratio problem more difficult ठीक है, when you are combining r minus y and g minus y, and when you are combining b minus y and g minus y, that's why r minus y and b minus y, these two signals are chosen by the transmission. So this is all about your color difference signal and unsuitability of g minus y signal. So we will stop here. Thank you.